Rohini College of Engineering and Technology. I am Vetrivel, Assistant Professor, Department of Physics, Rohini College of Engineering and Technology. In this video, we are going to discuss about the intensity of electromagnetic waves. Now let us see the primary astrophysical process producing electromagnetic radiation. When charged particles change direction, that is, they are accelerated, they emit radiation. Quantum systems, example atoms, change their energy state by emitting or absorbing photons. Here we see the electromagnetic spectrum. Start from gamma rays, X-rays, ultraviolet region, and infrared, middle infrared, thermal infrared, microwaves, radio waves. So for all these are the different type of electromagnetic waves. Their frequencies and the wavelengths are varying from one value to another value. Here we see the left side, the violet ray, blue, green, yellow, orange, red. They are changing their wavelength from some around 4.00 to some 0.710. So these are the ranges for the different wavelength of the electromagnetic spectrum. So in this picture we can clearly see how the electromagnetic waves are moving from one place to another place. Electromagnetic waves are nothing but the electric field and magnetic field vectors are acting in perpendicular as well as opposite direction. As a result, the waves are moving from one place to another place. Here how the electric component vectors and magnetic component vectors are rotating or moving from one place to another place. They are represented by the arrowheads with the different colors in this picture. Now let us see the properties of a plane wave of light. The wave equation is E is equal to Em sin kx minus omega t, B is equal to Bm sin kx minus omega t, and C is equal to omega by k, which is equal to 1 by root of mu naught epsilon naught, that is equal to speed of light. So lambda equal to 2 pi by k. E and B are always perpendicular to the direction of travel. E is perpendicular to B, that is E cross B, the direction of travel of the electromagnetic waves. E and B both vary with the same frequency and in phase. Speed of wave is independent of speed of observer. Wave doesn't need a medium to travel in. Now let us see how our eyes are very sensitive to the sensitive to differentiate the various colors. That means electromagnetic spectrum in general. Here we see along the x-axis the wavelength is given, and along the y-axis the relative sensitivity is given. Depends on the the intensity or the sensitivity of the eye. The colors will be varied, light color, dark color, or bright color, and so on. So in the x-axis the wavelengths are given in nanometer, 400 to 700 nanometer, and the y-axis the relative sensitivity is given from 0 to 100. A point source of light is one that emits isotrophically, and the intensity it falls off as 1 by r square. Here let P be the power of the source in joules per second. Then the intensity of a light at a distance is I equal to P by 4 pi r square. So in this video we can clearly see how the intensity of the electromagnetic spectrum is varying depends on the wavelength. Thank you.